Now, after that question of molecular orbital theory, we're back with another question on finding out which compound is more soluble in water and which has a higher boiling point. The two compounds in front of us are orthohydroxybenzaldehyde and parahydroxybenzaldehyde. So, Devansh, what do you think would be the approach to solving such a problem?
First of all, in this concept, the main point is we will learn about the hydrogen bonding and what types of hydrogen bondings are there and what are their impact.
Okay.
We know for any substance to be soluble in H2O, that is water, the more it forms bonds with water, it's more soluble.
Okay. I think the spelling of soluble has an L in it as opposed to being solube.
Yeah.
So, so more bonds with H2 is what we want, right? So, okay. So how do we measure that?
First of all, in orthohydroxybenzaldehyde, as you can see, this hydrogen is forming an intramolecular hydrogen bond ring with carbonyl group.
Okay. Okay.
And in parahydroxybenzaldehyde, it is not the case because they are very far.
Far away. Okay.
So when the solvent H2O approaches, they can bond interhydrogen molecular bonding with water.
Okay.
So in
will the H bond with the H or will the H bond with O?
H bond with O.
Oh, exactly. So students, keep this in mind that H will bond with an O and not with another H as such.
Yeah. So this is the most common mistake which students do.
So we should keep this in mind. So now that we know on the para position that H is going to bond with O, what does it tell us about solubility?
So in the parahydroxybenzaldehyde, it can form more bonds with solvent, that is H2O, as in ortho it is forming a bond between the two compounds are forming the bond between themselves, so they are not available for forming bonds with H2O, and if available also, so they are forming less bonds.
Okay, so which would mean consequently that because of intramolecular hydrogen bonding, the ortho is going to be less soluble in water while the para will end up being more soluble?
Yeah.
Okay, that was easy.
So the basic reason is intermolecular hydrogen bonding and intramolecular hydrogen.
Okay, so what about the second part of the question where we have to talk about the higher boiling point?
For higher boiling point, the basic concepts again come on hydrogen bonding.
Okay.
As you can see here, there is very less hydrogen bonding with water, so less number of bonds are there.
Okay.
So the energy to break this bond is suppose X.
Okay.
But here there are more number of bonds with solvent.
Okay.
So the compound will require more amount of energy to evaporate.
Okay, but Devansh, when we are calculating boiling point, we will calculate boiling point of a pure solution, right? We will not have any water. So we should actually be focusing on the bonds it will have with itself and the other similar molecules in the compound, right? Not with the solute.
This is the case when the solution is pure.
Okay.
But here we are talking about in H2O.
Okay, so we are actually calculating the boiling point in H2O and not for the pure liquid?
Not for the pure liquid. For pure liquid, the case will be again the same because for intramolecular hydrogen bonding, the bond it bonds hydrogen bond with itself.
Okay, it bonds with itself. Alright.
So very less bonding is there between the two different atoms of the same compound.
Okay.
Whereas in intermolecular hydrogen bonding, it will form bonds with different molecules of the same substance.
Okay, so as a result of it, it's going to be very strongly attached with the substance next to it and will consequently have a higher boiling point.
Yeah.
So whether we're talking about a pure solution or a pure solution or say a solution in water, we understand that intermolecular hydrogen bonding will result in a tighter bond, a stronger bond, and consequently a higher boiling point as well as higher solubility.
Yeah.
Which, if you look at it, are two entirely opposite concepts as such.
Yeah.
Because if you understand, if something is more soluble, it means it's dissolving better in a compound. And if it's more soluble, it will also have a higher boiling point because getting it out of the substance it's in, whether it is a solution or whether it is other molecules of the same, it will be consequently more difficult because the bonds will be stronger.
That is what is happening in intermolecular hydrogen bonding, na?
Okay,
because
wonderful.
it is getting more number of bonds, so it's more soluble.
Okay.
And that's why it's requiring more energy. Apart from, now let us see in the solvent from H2O to, let us see acetone or benzene.
Okay.
This is a non-polar aprotic solvent and this is a non-polar solvent.
Okay.
But still, in this same case, the answer will be same because here there will be more hydrogen bonding between each of the molecules. For this case, intermolecular hydrogen bonding will be more for para-hydroxybenzaldehyde.
Okay, so what part of the para-hydroxybenzaldehyde will associate itself with the benzene?
No part will associate, but it will associate with itself only, na?
Okay, so regardless of the solvent that we have present or available with us, we still know that whether it is polar or non-polar, para will be more soluble.
Yeah. No,
And
I am not talking about solubility. I am talking right now about boiling point.
oh yes, we have to be very careful and we very carefully
This is
associate
for-
boiling point and solubility separately. Please do not confuse the two of
boiling
those.
point will be more because your intermolecular hydrogen bonding, so the compound will bond with itself only in
Itself
benzene
more.
and still it will require more energy.
Okay, so it will be Bohr or will it be more?
It will be more.
The boiling point.
Oh, sorry.
Alright. So now that we've understood very clearly what are the different factors we need to look at boiling point and for solubility, let's have a quick recap. So for boiling point, we need to look at the kind of bonding it has with itself and also with, say, the solvent it is within.
Yeah.
For solubility, we primarily need to look at the kind of bonding it has with the solution it is going to be dissolved in.
Here only the solution is important. Here solution plus itself.
Okay, so
This
when
is
you mean
for
here
boiling-
and here,
This is for boiling point and this is for solubility.
alright, so now that we're done with a quick recap, let's move on to the next question. After tackling a problem related to boiling points and solubility, let's look at another one which talks about amongst AgCl and NaCl, which has a higher melting point. Now the first thing we need to understand is about chemical properties is that they're all a subset of the kind of bonds and the kind of intermolecular and intramolecular interactions that are occurring within the compound itself and in the medium that the compound is present in. So Devansh, how do you think we should tackle this question?
As we know that AgCl and NaCl both are ionic compounds, and for ionic compounds melting point is directly related to ionic character. The more the compound is ionic, the more will be melting point.
Okay, so the more ionic its nature, the more its melting point is, which means
Yeah.
a higher melting point, which means the more ionic it is, the stronger it is bonded,
and hence
you need to provide it greater energy to be able to melt it.
yeah.
Okay.
In this question, the anion Cl minus is same.
Okay.
So
yeah.
our main focus will be on Na plus and Ag plus cations.
Okay. So what about these two cations will we now try and understand?
First of all, the Na electronic configuration is Ne 3s1,
Okay.
and so Na plus by giving an electron attains a noble gas configuration.
All right. And we understand that the stabler the compound is, the greater is its dissociation.
It's more easy for the compound to form a cation, and hence it will have a low ionization energy.
Okay, so it'll be easier for it to be ionized. Okay.
So low IE. And whereas in the case of Ag, the compound is 40 10 plus 1.
So you mean its outer shell configuration is 4D10 and 4S1, or will it be 4D10 and 5S1?
It will be 40 10 plus 1. So Ag plus will become 40 10, which is a pseudo noble gas configuration.
Okay, and we know based on the octet rule that a noble gas configuration is more stable than a pseudo noble gas configuration. Therefore, atoms would tend to form noble gas configurations easier than pseudo noble gas configurations.
Yeah. Therefore, the ionization energy for Ag plus compared to Na plus will be more.
Okay. So this is ionization energy that you're talking about. Okay.
Yeah.
So consequently, Na plus will be more.
So therefore, Na plus will be more easily formed.
Okay.
As it require a very less ionization energy, and for the formation of an ionic compound, if a compound forms with a low ionization energy, as here
Sodium plus. Okay, so if it's low IE.
because for formation of an ionic compound you need ionization energy for this cation
Okay.
and electron affinity for an ion,
Okay.
and as here Cl minus is common for both,
Okay.
therefore on basis of IE
Okay.
NaCl will be more stronger.
So when you say more stronger, what do you mean by more stronger?
More stronger bond will be formed between Na and Cl.
Okay.
Na plus and Cl minus,
Okay.
and hence NaCl will be more ionic.
Okay. And what effect will it have on the melting point?
And as we know that melting point is directly proportional to ionic character. Therefore,
Okay, so is it the same as the logic that we were applying the last time around? That so if there's greater ionic character, the kind of bonding between different molecules will be stronger, and consequently the melting point will be higher. The same way as in the last question we were relating how because of greater hydrogen bonding between the surrounding molecules, they would adhere closely to each other, and therefore they would have a higher boiling point.
Yeah.
Does the same logic apply here?
yeah, the same logics apply here because here the compounds we are comparing two ionic compounds.
Okay.
And for them we have to compare with ionization energy and electron affinity.
Okay, so basically, as we said right at the beginning of the question, that it's primarily about understanding how these interactions between compounds happen and what are the forces that dictate these interactions. So once we're able to understand that, we will be able to solve any problem related to it, whether it comes for IIT JEE or for any other examination.
Yeah.